Long multiplication with decimals. Hopefully you've seen the previous videos about short multiplication and long multiplication. This time we're dealing with numbers which have decimal points in them. In our previous videos we've already talked about the idea of multiplication being like a bully. And this helped us to set out the question properly. We also talked about pivoting previously, and that helps us to do the method in the correct order. But there are some things which are different when multiplying decimals. When we set it out, the decimal points don't need to line up. Also, the biggest number doesn't have to go at the top. Let's look at that now. Many children look at these numbers and think the biggest number has to go at the top. So they put the 3.5 at the top because they know that 3 units is bigger than 2 units. They also think that they need to line up the decimal points like they do with column method. But we're not doing column method. Column method is only for adding and taking away. Multiplication is special, and especially when we have decimals. So, let's think about this. The decimal points don't need to line up. Instead, we need to remember how we did it in the last videos. The multiplication sign is like a bully. It pushes the numbers up against a wall on the right hand side. Now we don't have to draw this wall in every time. We can just imagine it, but we will draw it in again this time. So now we have a wall on the right hand side. Our numbers are not pushed up against the wall though. Only one of them is. 2.09 is right up against the wall. The 3.5 isn't. So let's move that across. Is that good enough? No, there's still space here, and the digits are not lined up. So let's move it across further. Now we have our digits lined up, and both the numbers are pushed up against the wall on the right hand side, just like a bully likes to do. Now let's look at our second point. The biggest number doesn't have to go at the top. Now this could seem very strange, but we have to remember that multiplication is special. Instead of putting the biggest number at the top, we're going to put the number with the most digits at the top. 3.5 has how many digits? And now we're talking about the number of digits in the whole number. Well, it has 3 and a 5, so that's 2 digits. The 2.09 has 1, 2, 3 digits. It has more digits. So we want to put the 2.09 at the top. That will make things easier later on. We still want to keep these numbers pushed up against the wall, and we want the digits to line up. Now pivoting. Pivoting helps us to do our multiplication in the right order. Nothing really has changed since the last videos, except that we have decimal points here in the numbers. So as we can see, we're still going to do 5 times 9, then 5 times 0, then 5 times 2. Then we're going to cross out the 5, any numbers at the top, and move across to the 3 and put a 0 at the bottom because we've moved across now to the 3, which the place value of that column is 10 times bigger. So we're going to put a 0 at the bottom before we start doing 3 times 9. Then we're going to do 3 times 0, and then we're going to do 3 times 6. Now let's do it. 5 times 9 is 45. So we put the units down here, we put the tens in the next column, and that's 4, and we try to put it in the center of that column. 5 times 0 is 0, plus 4 is 4. Now, I haven't quite lined that up exactly right, so let's just move that across slightly. Okay, now my digits look more lined up. Now we still have to do 5 times 2, which is 10. We leave the units here. The tens would normally go in the next column, but there's nothing there, so we're going to write it down the bottom. Now, we're finished with the 5, we're finished with the 4. We're going to move across to the 3, but because the place value of this column is 10 times bigger than this one, we're going to put a 0 down the bottom. I like to think of cross it out and then moving across, put a 0. Now we can do 3 times 9, which is 27. We put the units down the bottom, and the 2 we might think goes in the next column from the 7, because the 7 is lined up with these digits, isn't it? We might think that the 2 goes over here, but it doesn't. Why not? It's because we've just done 3 times 9. The next multiplication we have to do is 3 times 0. So that 2 needs to go above the multiplication we're going to do next. So 3 times 0 is 0, plus 2 is 2. Finally, we're going to do 3 times 2 is 6. Now, let's add them up. We're going to draw a line in. We're going to put our addition sign. Now let's add them. 5 plus 0 is 5. 4 plus 7 is 11. So we leave the units here. The 10s go in the next column, and it goes exactly in the middle of that next column. So we have 1 and 0 and 2, which is 3. And then we have 1 and 6, which is 7. Now, we are not finished. And that's because we haven't put our decimal in the right place yet. A lot of people maybe think that we just line up the decimal point. Some people even put the decimal point in all the way down till they get to the bottom. And they put the decimal point in this one all the way down to the bottom as well. And they think they've done the right thing because they've kept the decimal point lined up. But what that results in is an answer with 2 decimal points. Can you have a number with 2 decimal points? No, you can't. So let's get rid of those. How are we going to put in our decimal point? Well, let's just remember multiplication is special. It's special because the biggest number doesn't have to go at the top. The decimals don't have to line up the decimal points. And another reason why it's special is because we only put the decimal in at the end. And how we do that is by adding the number of decimal places. 2.09. How many decimal places is that? Well, after the decimal point, it has 2 decimal places. I like to write a little 2 next to it with a circle around it. 3.5 has 1 decimal place after the decimal point. Let's write that down with a circle around it. So what's the total number of decimal places? 2 and 1 makes 3. A quick way that I sometimes do it is I just go 1, 2, 3. And that means that our answer must have 3 decimal places. So start with the place value which is smallest and count 3 digits, 1, 2, 3, and then afterwards put your decimal point in. We can check this is in the right place by counting the decimal places after the decimal point. So after the decimal point there is 1, 2, 3. Is that what we wanted? Yes, we wanted 3 decimal places. There is another way to check that we have our decimal point in the right place, and that's by using approximation. Our top number is about 2. If we rounded that to the nearest whole, it would be 2. Our bottom number is about 4. It's actually halfway between 3 and 4, but if we were rounding to the nearest whole, it would be 4. So this is 2 times about 4. So our answer should be about 8. 2 times 4 is 8. Is our number close to 8? Well, it's 7.3, meaning it's bigger than 7, isn't it? So yes, it's quite close to 8. If we had our decimal point in a different place, we can check if it would be closer to 8 or not. Like, for example, if our decimal point was here, then it would be 0.7 something. 0.7 is sort of getting close to 1 whole. 1 is pretty far from 8. It's not that close. It's not as close as 7.3, is it? What about if we put the decimal point in another place? Let's say someone might put it there accidentally. Now the answer would be 73 point something. 73 is not close to 8. And it would be even worse if we had the decimal point here, because the answer would be 731. That's nowhere near 8. If we had no decimal point at all, or the decimal was at the end here, meaning 0.0, 3,715 is nowhere close to 8. It's getting further and further away, isn't it? So that is a way to check that we have our decimal point in the right place. If it is in the right place, it should be close to a number, to an answer that you can estimate using rounding of these two numbers. So our answer is 7.315.